Good afternoon, everyone. I am Maria Balota. I am a faculty at the Tidewater Agriculture Research and Experiment Station, and I am the leader of the Peanut Variety and Quality Evaluation Multi-State Project. Today I am going to present to you a peanut variety update, the one that I have made last week at the peanut meeting. My talk is going to include a summary of the last year peanut crop. I will briefly update you on the commercial cultivars that are currently available. And then I will describe to you several comparisons between cultivars and breeding lines, including yield, grade, stand count, and vigor, and information on insects and diseases as well. I will end up presenting a couple of recent results from agronomic trials that I also run. Okay, I will start presenting to you a comparison between max and mean temperature of the last year, the blue bars, compared with 85-year average max and mean temperatures, which is the orange line. And what we experienced last year was quite a normal, if we can call it this way, maximum temperature for May, June, and July, but much higher temperature in comparison with the multi-annual temperature for the rest of the season, August, September, and October. Minimum temperature, however, with the exception of May, recorded much higher in 2021 relative to the average of 85 years. So yes, we are on the hottest side of the weather last year, and as we have been in the past few years. What does this mean for peanut production? Well, that will definitely affect the accumulation of the seasonal heat units. And in this graph, I'm showing you how degrees units were accumulated in 2021 relative to 18 years average, which again is the orange line. So basically, for peanut to mature, we need around 2,700 heat units. And in the past, we were able to reach this somewhere in mid-October, towards the end of October. But in more recent years, actually, this is being achieved already in much earlier. For example, in 2021, that was received by the end of September. So I don't know whether peanut maturity under these conditions is something that we should worry about, as it looks rather than peanut can mature optimally and on time before late freezes pretty much easily because of the higher temperatures that we are seeing recently. Precipitation is also different than what we used to see, with huge fluctuations from one month to another. For example, last year, May was very dry. I know that some growers actually postponed planting to early June because soil moisture was not sufficient. Also, September was quite dry last year in comparison with the multi-annual precipitations. At the opposite side, July and August exceeded by far the multi-annual. Now we are increasingly seeing more um, um, problematic distribution of this precipitation. And here is the data from Suffolk. As you can see, in May, just very little precipitation. In September, just like I said, but also times of anywhere 5 to 10 days when precipitation was absent. And this is a problem because our soils are sandy, they lose moisture very fast. The peanut vines are really big. We are expecting a high biomass and high yield from the new cultivars, and these pose serious problems. Under the conditions of a very dry May at planting time, and then abundant precipitation that we got all at once, basically in June, some fields looked a little yellow, and some growers were concerned that maybe um, peanut does not have enough nitrogen, and they wanted to apply ammonium sulfate. The best thing to do when you have doubts about whether to apply or not nitrogen is just to pull out some plants and look at the nodules on the roots number. And indeed, in these pictures, maybe the numbers are a little lower than we used to see in most of years, but they are not at a critical point by any means. And beside the number, just open up please a nodule and look at the color. If that color is pink or red, that means that the nodules are healthy and working properly, and you should not worry about. Rather, give time of these plants to recover after a dry May and too much moisture right after that. So two precipitation extremes that might have affected uh, the plants. So basically, in the end of July, because of the weather conditions that I just tried to describe to you, here is where the peanuts were in terms of maturity. But what I actually want to show you is rather that it was a huge variation in seed development at that point in time, just because I think because of the dry spells that the crop encountered throughout the growing season. When put on a maturity chart, Bailey 2 at your left and Walton at your right, they are somehow looking similar. In the end of the season, what I noticed, I don't know whether growers experienced this as well, but we certainly did, and that was the case for the very large potted and seeded varieties that probably required more calcium, more land plaster that we applied and we are used to apply. We observe disease, and this is not sclerotinia blight like we would have thought close to digging, but it is southern stem rot based on observations and of our plant pathologist, Dr. David Langston. Okay, a little more information about other locations throughout the VC region. We are testing varieties in Virginia but also at certain locations in North Carolina and in South Carolina. And the heat units accumulated throughout the VC region varied dramatically. For example, at Blackville in South Carolina, heat units needed for the varieties to mature were reached in the end of August, end of September for Suffolk and the northern locations in North Carolina, and mid of September for southern part of North Carolina. In terms of precipitation across these locations, you can see the variability here. Most locations did not receive proper precipitation in May, indeed. Abundant in June, some more in July and August, and September went again quite dry, just like us here in southeastern Virginia. Each location, the distribution of the precipitation in each location was also very different. For example, in South Carolina at Blackville, there were more frequent rainfalls than at Slade Farm, for example, near Williamston in North Carolina, where peanut actually suffered pretty serious drought this year. All right, now let's talk a little bit about varieties. And here it is the first Bailey 2, which is the high oleic version of Bailey. Some of you already grew it in 2021, and more seed will is available for 2022. Just like Bailey, Bailey 2 is resistant to leaf spot, sclerotinia blight, and marrow-spotted wilt. And it matures in about the same number of days, 140 days after planting. And it is a larger seeded variety than Bailey. Walton was released in 2019. Walton was released as a drought-tolerant variety. The it has smaller seeds than Bailey 2 and Emery, but it has similar agronomic performance, and it also has resistance to leaf spot, white mold, and marrow-spotted wilt virus. And finally, NC20. This is a new release. Actually, it was released in 2020 at NC State and by their peanut breeding program. And the reason for release of NC20, it is its excellent resistance to leaf spot. Actually, in trials, the peanut breeder noticed that NC20 keeps high yield even under no treatment for leaf spot. Okay, this is one of the tests that I would like to present to you the results. And this is a peanut variety and quality evaluation in 2021. This test included 25 cultivars, 5 cultivars, and 20 breeding lines. And any of these breeding lines actually can become the new peanut cultivar that will be available to you for planting in the future. So we always plant the commercial cultivars as checks, because what we want eventually to do is to make sure that the new releases are exceeding the current cultivars. This slide shows yield comparisons in 2019, 2020, and 2021 at all Pbqe locations and in average across all locations. In Suffolk and at Williamston, North Carolina, we usually plant 2 digging dates. The first digging date that we dig about 2 or 3 weeks sooner than the optimum maturity, and dig 2, which is actually a digging performed at the optimum maturity of the peanuts. By digging earlier, we want to monitor how much yield can be lost if growers are digging a little earlier than they should. And also we want to observe the maturity, the earliness of each of the breeding lines that stays in the test. So in average of all locations, these are the numbers. 2021 exceeded in yield the 2020, which is in agreement with what you guys have seen in the field, but it did not 2019, which appeared to be a better year for peanut than the next 2 years, the last 2 years. This is a simple comparison from the Pbqe trials of separately by location, Suffolk, Virginia, and Williamston, North Carolina, of yield difference between dig 1 and dig 2. And bottom line is that rushing digging can reduce yield up to 15%. That's all I wanted to show you with this slide. Here, I'm showing you data from 2021 across all Pbqe trials for yield and for SMK. The first 5 bars represent Bailey 2, Emery, NC20, Sullivan, and Walton. So they are our checks, our varieties available to you. And all the others represent the breeding lines that could become available to you as future cultivars. So for example, yield last year was the highest for Emery, followed by NC20, then Bailey 2, then Walton, and on the last yield was Sullivan. You can notice that some of the breeding lines were actually as high in yield as Emery. For example, this N15044 or N17047. In terms of SMKs, which is a plus when it comes to the dollar value that you're getting from a peanut crop per acre. Number 1 last year was Bailey 2, followed by Walton. And then was Sullivan, and much lower SMKs was noted for Emery and really low for NC20 for some reason. But other of the breeding lines actually exceeded Bailey 2, for example, N17045. This is a comparison of the checks and the breeding lines across all locations of the Pbqe trials last year for ELK and dollar return per acre. Many of you are processing peanut as well, and you may want for gourmet products, canned peanuts, etc. You may prefer to have a larger peanut size, like higher values of the ELK. And indeed, the dollar return per acre can come from the number, smaller peanuts, but larger number, or it can come from the size, larger peanuts and larger SNKs as well. So it is always what you want to grow the peanuts for. With a larger seed, yes, that's fine. You can sell those as gourmet products, but you will pay more for seed at planting. For smaller peanuts, you pay less for seed at planting, but you need to find other ways to use that cultivar. For ELKs, Bailey 2 was the highest, followed by Sullivan and Emery. Then Walton, and NC20 was the smallest, it appears. But many other new breeding lines that NC State has available and made available for testing actually are as large as Bailey 2 or larger. When it comes to the return per acre, the best was Emery, followed by Bailey 2, Walton, and NC20, and Sullivan was on the last place among the cultivars. The same, there are quite a few promising breeding lines that seem to ensure that you will get a good dollar return per acre if released as new cultivars. Some of the breeding lines we are, and we just started these 2 years ago, we are testing them under really dry weather conditions, under the rain exclusion shelters. We plant them, we let them grow, and in July, for a month, we cover them to exclude rainfall, and after that, we move back the rain-out shelters and monitor yield and grade and the response of each variety to this dry imposed season. Bailey 2 was used as a check in this experiment, and all the others are breeding lines. The yields were anywhere from 2641 pounds per acre to a little over 4,000, and actually N17045 stood up as the best in response both for yield and dollar value under this drought regime. So this is quite a promising breeding line to be released for dry regions and dry fields in the future. This is another test that I would like to present to you. I call it VTUF, that stands for University of Florida, and it is a collaboration between me and the peanut breeder at the University of Florida. We are trying to use a different genetic background source to see how the breeding lines are fitting in our region. I would assume they have at least better heat tolerance because from where they are coming. And Walton, for example, was released from this test. In 2021, we had 10 breeding lines and 5 checks. Briefly, the results. We planted them at 3 locations in Virginia and at Lewiston in North Carolina. And the bars represent here the average of all checks and breeding lines. Just for you to see the variation in yield due to temperature and precipitation. The highest was at World Farm here in Suffolk, Virginia, with an average of almost 5,000 pounds per acre and almost $1,000 per acre return. But then we had Lewiston, where I just told you it was very dry, May and September, and yield was just half. And the same was the dollar return per acre. In terms of trips, vigor, we monitor the vigor of each plot, leaf spot and tomato spotted wilt. The numbers were pretty much all over the place. But you can note that the vigor, we want this bar to be higher, the vigor to be higher. They were pretty close at 3 of the 4 locations, a little less vigor at Darden Farm, but that was not necessarily detrimental to yield, as you can see on the graph to the left. In terms of insects and disease, Darden was less affected, but at Lewiston, plants were under severe leaf spot disease and thrips damage. And now the results for each individual check and breeding line. We have Bailey 2, so we have first yield, and then we have return, the dollar per acre. The best yielders were Emery, Walton, and NC20, followed by Bailey 2 and Sullivan. And this is the average across all these 4 locations I showed to you. In terms of return, again, Emery, Bailey 2, and Walton were the winners, so to speak, and NC20, followed by Sullivan. Please remark a couple of breeding lines that certainly exceeded in yield and in return Bailey 2 and Emery. I marked them in red rectangles and green, because the ones in green, I'll show you, they have larger seeds, as well as the ones marked in red rectangles, they have high yield, but the ELK is a little low. So small seeded versus larger seeded breeding lines. This is basically what I was talking about earlier. Bailey 2 had high SMKs, but not higher than Walton. Emery, followed by Emery, Sullivan, and NC20, again had a smaller SMK for some reason last year than any of the other cultivars. But you can see, and the ELKs were Bailey 2, so the largest was Bailey 2, then Emery, Sullivan, NC20, and Walton. Again, with a few of these breeding lines that are at least at the level, if not exceeding, those checks. In terms of thrips and leaf spot, probably the most outstanding in terms of yield and as well ELK and SMK and dollar return per acre, was this particular line 13 by 101-4-5-2-1-B. So there is hope there that the breeding lines that we are looking at, both in the Pbqe and in the VTUF trials, they include breeding lines that are very promising future cultivars for you. Okay, now I will switch gears to agronomic trials that we researched last year and in the past few years. So, for example, for some time, we were looking at comparing irrigated versus non-irrigated trials to see how much can we get from irrigating the plots when we don't have rainfall in a particular week. This is a graduate student project. We are also looking to see within the same test to see whether which are more profitable, Virginia type cultivars or the runner cultivars, because I know that sometimes growers will prefer to grow runners. So altogether from 2016 and through 2020, and including location, year, and irrigation regime, we tested these 2020 runner and Virginia type cultivars in 13 environments. Okay, it's very important that we have cultivars available that are doing performing well not in just one field but across a larger region, and this is basically the scope of another scope of this test. So this picture shows, this graph shows pod yield of rain-fed in red versus rain-fed plus irrigated trials in blue. And you can see that at certain locations, irrigation produced significant yield versus non-irrigated trials. But at some other locations, in certain years, not so much. For example, here at Capron in 2017. So I calculated altogether what's the plus of irrigation, supplemental irrigation of in average 1 inch per week when that week was not receiving rainfall, and that was right around 10-11% increase in yield. The bottom part of this figure compares runners and Virginia type cultivars. So we wanted here to see in each of our 13 environments what market type performed better. And certainly in the majority of them, they were quite similar in yield, but in some, for example, Suffolk in 2020 and Rocky Mount in 2017, both irrigated and non-irrigated trials, Virginia type produced better than the runners. But it was another environment like the one in Dinwiddie in 2016 where it was just the opposite. So in general, I would think that Virginia type produced better in our environment than the runners. And this is something that probably you have seen and I have seen over and over again, just because the Virginia type are bred for this environment, because they are early maturing than the runners. this definitely gives them a good competitive attitude versus runners. But it's good to know, again, which are my most reliable cultivars that if I choose to plant, and I want to choose only one or two, no more, then which are the ones that will give me consistency when it comes to yield and dollar return. And this is what the stability index does. And the graduate student did this analysis. And here, the smaller the numbers, the more stable that variety is. And so the most stable across a larger number of environments, cultivars were Sullivan. Sorry that Sullivan is showing recently a decrease in yield, and Bailey. And this is not Bailey 2. This is just Bailey. But I could not have, I didn't have Bailey 2 at the time when we started this test to include. Win, on the other hand, which is obsolete right now, had less stability. Win was good only in certain environments, but not in all, across the board. Okay, this is another test that we started last year in collaboration with all agronomists in all peanut growing states. We wanted to look at the effect of in-furrow applications of 7-17-3 micro fertilizer riser by Nutrien, whether it has an effect on yield or rather has an effect on germination, because some agronomists in Georgia, for example, they noticed that riser actually reduced germination and became problematic for a good and uniform stand. So we look at this, and we had we use for this only Bailey 2. We had an untreated trial. We applied 0.5 gallon per acre riser, 1 gallon per acre, 2 gallons, and 3 gallons per acre. That were our treatments. Stand count, you certainly can see the decrease. That's a sharp, uniform decrease in stand count from about 150 seeds that we were planning per plot to only 50 when riser was used at the maximum rate. Now, peanut is a great crop that compensates really well. So in this particular test, it compensated really well the decrease, the moderate decrease in stand count, so that the yields of the untreated 0.5 and 1 gallon per acre riser, they were not quite different from each other. But then when the riser rate increased over 2 gallons per acre, yield was also significantly decreased. We will continue to do the test for a second year and maybe another year, and we will combine the information from all 10-11 participating states, and we will publish these results. This, and I promise this to be my last information, is a test that we performed in 2017 and 18, looking at the effect of different inoculants on yield and value dollar return per acre. Now, my rotation is only a 3-year rotation, as opposed to yours, and that is 4 and longer, and for which the recommendations in the peanut guide are such that we encourage you to apply inoculant regardless every year. So because of the shorter rotation, I think that that's the reason why I think only in 2017 untreated yield and return was less than for any of the inoculant treatments, because in 2018 that was not the case. Again, I will not take the chance of not using inoculant just because in 2018 I did not get a response from inoculants, just because my rotation is very short. And in general, probably we usually use Monsanto optimized lift, which was quite consistent in supporting yield and good value return. But one that stood up also very good, and I'm willing to try in the future, is this Vision Biologics Exceed that was #1 in 2018 and helped quite a lot yield and value return in 2017. So yes, there is a large option of inoculants. Any of them, I think, are good to use rather than not apply inoculant, in particular under uncertain environmental conditions that we are seeing lately from one year to another. With this, my email number and my phone number are on this screen. You can contact me at any time if you have questions, or if you want me to look at the color of peanuts in your field and discuss with you why I think that might happen. I thank you for your attention, and I also want to mention that this work wouldn't have been possible without the help of my co-workers, collaborators from other states, and also the sponsors that are paying for this work.